Okay, so I'm going to build a remote control autonomous plane. A remote control plane, you throw it in the air and it'll navigate by itself from waypoint to waypoint. It'll control its own altitude, it'll control its own speed. If the wind tries to blow it off course, it'll correct for that itself, and then it'll come back home and maybe even land itself. I'll see how far we get with this. So this is the plane that I'm going to use. This is an RC Powers V4 F18. So this is built out of Depron, which is like polystyrene. It's a material they use under laminate flooring for insulation. It comes in great big flat sheets. Cut that out to the shapes for the plans dictate, glue it all together, and you end up with this. So you can see there's a bit of mud on the nose and whatnot, so I've crashed this a few times, but yeah, it flies really well actually, it's fine. It's probably not the ideal plane for this project. I think for this project you should probably use like a trainer style plane, something that's probably a high wing style, and maybe lots of dihedral. So basically a plane that flies itself. So if you let go of the controls, it basically levels itself and flies onwards. I think that would be easier. This is going to be quite challenging because it's low wing obviously, and also it doesn't behave itself too well at low speed. It likes to fly fast. So like if you're coming into land, this one's a bit of a pain. That's how it's covered in mud. It tends to tip stall if you go too slow. So yeah, this could be interesting, but I'm sure we'll have fun. So this year I got back into remote control stuff. Like I used to do it years ago, about 5-6 years ago. I actually tried this before, but I didn't get very far. But this year I've been flying quadcopters. In fact, I've got another one that I'm in the process of building up just now. So I've got a bunch of these, and these have been great. Having brilliant fun with these. But the same technology, so this board in here, this flight controller, this can be used to control a plane as well. So this is the flight controller. This is a Flip 32. I bought this from Banggood in China. I think it was about 12 or maybe £14 delivered. So pretty cheap. It came in this little case. I don't remember seeing this in the listing, but that's probably ideal for installing in a plane. If I can get this open. There we go. Yeah, so this wee case looks ideal. So this is the kind of brains of the outfit. On here, it integrates a whole bunch of stuff that you need for kind of flight control. So there's an STM32. This is an F1 microprocessor. There's a CP2102 USB to serial. There's a firmware or a bootloader firmware on this microcontroller, so we can actually reprogram it just by hooking it up to the PC with USB. So that's pretty cool. You don't need like an in-circuit serial programmer. Also, once the firmware is actually running on here, we can change like configuration parameters and whatnot. It can speak over the USB to serial connection, and we can fire in configuration changes if we want. As well as that, there's an accelerometer and gyro on here, so that gives you your full 6 degrees of freedom for flight control. This is I think they call this the deluxe version. So this has also got a 3-axis magnetometer, so we can get a magnetic head and lock. And there's also a barometer on there as well. So I think it's like centimetre resolution, so we can detect the changes in air pressure as we ascend and descend. So that's pretty cool. Besides that, there's some inputs and outputs. This input section here, you could use it for PWM input, so I'll put a picture up. This top one here is PWM input. This is the ability to send a serial signal without using a separate clock signal as well. So all the information is contained on basically one pin, which is pretty cool. So it's kind of like sending an analog signal but using a digital method, which is pretty interesting. In general though, with quadcopters, you would need one of those channels for every control surface. Same for planes. So you would have a lot of wiring. And it's more common to use a different scheme. So this is PPM, pulse position modulation. So the advantage here is that we can consolidate all those inputs. You could have 16 inputs or something on one pin. So that saves, you don't need all the wiring anymore, you just need one connection. It's not ideal for, all this stuff grew out of kind of remote control planes and helicopters and whatnot. It's not ideal for controlling servos and things like that, but for something like this, it's fine. but it's still it's not a strictly digital signal. There's no clock, so there's a possibility of jitter and skew getting into a signal as well. So there's another approach, which is just to use a digital serial port, so we can send packets of data over to say, this is what I've received from the receiver, so the input should be XYZ for each of these channels. So we're going to use that approach. Now this F1 processor or microprocessor has two hardware serial ports. One of them is used for this USB to serial connection. It's also broken out here. I'm going to use this for an on-screen display. We'll have like a first person view video feed from the drone, so you'll be able to see as you're flying, but I'll get to that later. The second serial port I'm going to use for the receiver. So this is a receiver here. You can see here there's lots of pins on this receiver. That's quite a big receiver. This is actually the receiver that was in the plane until I took it out. And I needed all these channels because there's so many different control surfaces. There's two servos for the elevators at the back. There's two for both the rudders. There's a servo for each of the ailerons and the wings. And also there's an output for the speed control for the motor. These receivers are brilliant. This is a FlySky IA10. It's not the one I usually use. I usually use an IA6B. It's a wee bit smaller than this, but it does everything. I use this one on this model because of all the outputs. But now that we're switching over to adding in a flight controller, which wasn't there before, I don't need all that. It's only going to be one pin connecting to the flight controller, this digital serial output. So we can do away with that. Because the plane's so big, I mean, usually I would switch to a smaller receiver in this case, but it doesn't really matter, so I'll just use this one. I did have to modify this a bit. I won't open it up again, but I had to modify it. It came with, for the digital connections, there's these two ports here. So this is an input for telemetry sensors, and this would be the output for the digital serial. So all I did was I desoldered this. I don't like these connectors, and I just soldered a wire directly onto the pad. I put in some hot glue there just for strain relief, so that if this gets tugged, it doesn't pull the pad off the PCB. So yeah, that's pretty much everything for that side of things. As I say, that'll plug into the flight controller on one of these pins here. I think it'll be pin 2. That allows us to send in signals from the remote control, so we can turn on different navigation modes based on a switch in the controller, or we can take over manual control if things are going a bit haywire. So that'll control that side of things. The other pins here, we also need a few other things. So let me grab this, shift all that out of the way. So this is a GPS input. So we've got pretty much all the other sensors we need already on that board, but we don't have GPS, and we're going to need GPS. This is an MAN sensor. This is from Banggood. I think this is about £15 delivered, which is pretty cheap. I used this earlier this year on a 3DR Solo. They come with an M7N GPS out of the box, but the configuration of them by the 3DR guys is really conservative. So it meant you would turn on the quadcopter and you'd be waiting like 3 minutes or something to get a GPS lock. From the factory, these are configured much more leniently, and also the dual constellation. So it speaks to GPS, but also speaks to the Russian system, the GLONASS system. It might even be tri-constellation. I've got it in the back of my mind that it speaks to the Chinese system as well. So that's pretty cool. As I say, I've used this before. I trust them. They're reliable. They're pretty good. They are cheap, so they're not going to be super reliable, but they're good enough for my needs. I changed the connectors. It came with those daft wee connectors, like that kind of style, and I don't like them. So I changed it just for standard GR plugs. So I crimped on new ends. So we've got two sets of outputs here. These are a serial port. And this is where the GPS chip's connected up to, and this is an I2C bus. There's also actually a compass in here as well, so we can choose which compass we're going to use, either the one on here or the one on here. I think they're actually the same chip because they're on the same address on the I2C bus, so I can't fly with both of those. I'll need to choose one or the other. I'm going to leave this one disconnected just now, but I can see myself disconnecting or desoldering that chip and using this one instead, but we'll see how we get on. So this also is going to connect up via digital serial. But we've already claimed both of the digital serial ports on the controller. So there's also the option to have a software serial port or two software serial ports. So basically the controller uses just a normal input-output pins, and it will speak the UART protocol in software effectively. So that's quite CPU intensive, and it means that we can't run as fast as the hardware peripheral would run. So software serial UARTs, they're normally about 9600 baud, but we can run it at 19200 baud if we only use one of them, and we only need one of them. The GPS by default is configured for 10 Hz update, which is great, but we probably don't need that frequently an update. I think we can get away with 5 Hz update. So we can turn down this by default, I think, is 38400 baud. So we could turn that down to the 19200 baud and speak over the software serial port. So that should all work out quite nicely. The only other hardware that I'm going to add in just now is one of these, a wee piezo buzzer. So when that flight controller's in the model, there's a couple of status LEDs over at the right hand side here for giving you details about what mode you're in or what's happening. But that's a pain in the backside, and having a wee buzzer just to give you kind of audible beeps and feedback for each of the different modes, that's quite useful. Also, when the model inevitably lands in long grass, it's useful to be able to switch that buzzer on so that you can find it again. So yeah, there's going to be some other stuff, an FPV camera, and there's going to be a wee FPV transmitter and all this kind of stuff, but that's going to be kind of phase 2. I guess the first thing I'm interested in is getting the flight control working. So let's set up the software on this. We'll get this working on the bench, and then we'll install it all on the plane.